Welcome to sureshbhattclasses. We are solving quantitative aptitude topic numbers. All the topics of quantitative aptitude are useful for all competitive exams like Bank PO, RRB, SSC, CGL, Railways, and many government job exams and job interviews. These videos are also useful for all entrance exams like GRE, SAT, ACT, CAT, GMAT and many more. Please watch all my videos on quantitative aptitude topics. In this video, we are finding number of zeros at the end of any given number or in solution of given question. Our question is, find number of zeros at the end of number 1 cube multiplied by 2 cube multiplied by 3 cube multiplied by, this goes up to multiplied by 30 cube. The given options are option A 24, option B 21, option C 20, option D 18. Before solving this question, I request you to please subscribe to this channel. In this question, we have to find number of zeros after solving this number 1 cube multiplied by 2 cube multiplied by 3 cube up to multiplied by 30 cube. And number of zeros at the end of any number is nothing else but the power of 10 in that number. And 10 consists of two prime numbers which are 2 multiplied by 5. So we have to find the power of 2 as well as power of 5. In this number, there are many even numbers which will give us many power of 2. So we have only to find the power of 5 in the given number, and that will be 5 to the power 3 multiplied by 10 to the power 3 multiplied by 15 to the power 3 multiplied by 20 to the power 3 multiplied by 25 to the power 3 multiplied by 30 to the power 3. Now we will add all the powers which contains the power of 5. In 5 to the power 3, the power of 5 is 3, plus in 10, it will be 5 multiplied by 2. Therefore, the power of 5 will also be 3 here, plus in 15, the power of 5 is 3, plus in 20 to the power 3, there will be the power of 5 which is 3, plus in 25, it will be 5 multiplied by 5, and 25 to the power 3 is 5 to the power 3 multiplied by 5 to the power 3. So the total power of 5 will be 6, plus in 30 it is power of 5 will be 3, and this sum is equal to 21. So there will be total power of 5 is 21, and power of 10 will also be 21, and this gives the number of zeros at the end of given number. There will be 21 zeros in the given number, and from the given options our answer is option B 21. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, which of the following cannot be the number of zeros in any factorial? The given options are option A 16, option B 17, option C 18, option D 19. Before solving this question, I request you to please subscribe to this channel. We have to find out of 16, 17, 18 and 19 which cannot be the number of zeros in any factorial. In 5 factorial, at the end of 5 factorial there is 1 0. At the end of 10 factorial there are 2 zeros. At the end of 15 factorial there are 3 zeros. At the end of 20 factorial there are 4 zeros. At the end of 25 factorial there are 6 zeros. At the end of 30 factorial there are 7 zeros. At the end of 35 factorial there are 8 zeros. At the end of 40 factorial there are 9 zeros. At the end of 45 factorial there are 10 zeros. At the end of 50 factorial there are 12 zeros. At the end of 55 factorial there are 13 zeros. At the end of 60 factorial there are 14 zeros. At the end of 65 factorial there are 15 zeros. And at the end of 70 factorial there are 16 zeros. So we have to start from 70 factorial. We divide successively 70 by 5. 5 divides 70 for 14 times. We again divide 14 by 5 and it divides it for 2 times. So 14 plus 2 is 16, and that is the power of 5 in 70 factorial. And that will also be the power of 10 in 70 factorial. So there will be 16 zeros at the end of 70 factorial. Now we go for 75 factorial. 5 divides 75 for 15 times, and 5 again divides 15 for 3 times. So there will be 15 plus 3 is 18. So there will be 5 to the power 18, and that will also be the power of 10 in 75 factorial. So there will be 18 zeros at the end of 75 factorial. Now we take 80 factorial. 5 divides 80 for 16 times. 5 again divides 16 for 3 times. So there are 16 plus 3 is 19. So there will be 19 zeros at the end of 80 factorial. But we could not find 17. In 70 factorial there are 16 zeros. In 75 factorial there are 18 zeros at the end. In 80 factorial there are 19 zeros at the end, but we could not find 17. We have to check the number in between 70 and 75. If we take say 72, 5 divides 72 for 14 times, and 5 again divides 14 for 2 times. So there will again be 16 zeros in 72. Similarly, it will be 16 zeros in 73 factorial, and it will be the same in 74 factorial. So from 70 to 74 there will be 16 zeros, and 75 to 79 there will be 18 zeros, and in 80 there will be 19 zeros. So there will not be 17 zeros in any factorial. And from the given options, our answer is option B, 17. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, what will be number of zeros at the end of number 35 factorial raised to power 3 factorial? The given options are option A 10, option B 24, option C 41, option D 48. Before solving this question, I request you to please subscribe to this channel. Number of zeros at the end of any given number is nothing else but the power of 10 in that number. So we will find the power of 10 in 35 factorial raised to power 3 factorial. As 10 is not a prime number, we have to split this into two prime numbers, which are 2 multiplied by 5. And we know that the power of 2 will be more in 35 factorial than power of 5 in 35 factorial. So we will find only the power of 5 in 35 factorial, and that will be the power of 10 in 35 factorial, and that will be the number of zeros at the end of 35 factorial. We divide successively 35 by 5. 5 divides 35 for 7 times. 5 divides 7 for 1 time, and 7 plus 1, 8 is the power of 5 in 35 factorial. So there will be 5 to the power 8 raised to power 3 factorial. This gives 5 to the power 8, and 3 factorial is 6. So this will give 5 to the power 8 times 6 is 48, and therefore there will be 48 zeros at the end of given number 35 factorial raised to power 3 factorial. And from the given options, our answer is option D, 48. I hope you have understood the method of solving such type of questions. We go to next question. Our question is, find number of zeros at the end of number 10 factorial raised to power 5 factorial plus 20 factorial raised to power 10 factorial plus 30 factorial raised to power 15 factorial. The given options are option A 240, option B 200, option C 270, option D 210. Before solving this question, I request you to please subscribe to this channel. In the given number, we have just to find number of zeros at the end of 10 factorial raised to power 5 factorial, and that will be the answer for the given question. And number of zeros at the end of any number is nothing else but the power of 10 in that number, and 10 is equal to 2 multiplied by 5. So we will find the power of 5 in 10 factorial raised to power 5 factorial. First we will find the power of 5 in 10 factorial. We divide 10 by 5 successively. 5 divides 10 for 2 times. So number of zeros will be 2 at the end of 10 factorial. But we have to find the number of zeros at the end of 10 factorial raised to power 5 factorial. So the power of 5 in 10 factorial is 2, and it has the power 5 factorial. This is equal to 5 to the power 2 raised to power 120, as 5 factorial is 120, and this gives 5 to the power 240. So there will be 240 zeros at the end of given number, and from the given options our answer is option A, 240. We go to the next question. Our question is, if n plus 1 factorial has 2 more zeros than n factorial at the end, how many 2-digit values of n are possible? The given options are option A 2, option B 3, option C 4, option D 5. Before solving this question, I request you to please subscribe to this channel. The number of zeros at the end of 5 factorial is 1, and it is 1 only up to 9 factorial, and number of zeros at the end of 10 factorial is 2, and it continues to be 2 up to 14 factorial, and in 15 factorial the number of zeros are 3, and 15 factorial to 19 factorial the number of zeros are 3, and in 20 factorial number of zeros are 4. So there is only the gap of 1 in between 19 factorial and 20 factorial. If n is 19, then n plus 1 will be 20. So there will be only change of 1 0 in between 19 factorial and 20 factorial. And 20 factorial to 24 factorial, the number of zeros are 4. And in 25 factorial, number of zeros are 6. So if n is 24, then n plus 1 will be 25, and there will be difference of 2 zeros in between 24 factorial and 25 factorial. So n equal to 24 will be our first number. So if n is 24 factorial and n plus 1 will be 25 factorial, in between 24 factorial and 25 factorial, there is a difference of 2 zeros at the end. Similar is the case when n is 49, so n factorial will be 49 factorial and n plus 1 will be 50 factorial. In between 49 factorial and 50 factorial, there is a difference of 2 zeros at the end. In 49 factorial, there are 10 zeros, and in 50 factorial, there are 12 zeros at the end. And in between 74 factorial and 75 factorial, there is the difference of 2 zeros at the end. And again, in 99 factorial and 100 factorial, there is a difference of 2 zeros at the end. Therefore, n has 4 values for which n and n plus 1 has difference of 2 zeros at the end, and those values of 2-digit number of n are 24 factorial, 49 factorial, 74 factorial and 99 factorial. So these are the 4 values of n. All the 4 numbers are 2-digit numbers as asked in the question. If the question had been asked for n plus 1, which are 25, 50 and 75, as 100 is not a 2-digit number, it is a 3-digit number. And from the given options, our answer is option C, 4. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find number of zeros at the end of the number 1 to the power 1 multiplied by 2 to the power 2 multiplied by 3 to the power 3 multiplied by, this goes up to, multiplied by 100 to the power 100. The given options are option A 1000, option B 1200, option C 1300, option D 1500. Before solving this question, I request you to please subscribe to this channel. The number of zeros at the end of any number is nothing else but it is power of 10 in given number, and power of 10 is same as power of 5 in given number, as the 10 is equal to 2 multiplied by 5, and there will be many more power of 2 than power of 5 in given number. So we will only find the power of 5 in the given number. In the given number, there will be 5 to the power 5 multiplied by 10 to the power 10 multiplied by 15 to the power 15, and this goes up to multiplied by 100 to the power 100. So the total power of 5 will be nothing else but the sum of the powers of all these numbers. So it will be 5 plus 10 plus 15 plus, it goes up to plus 100, plus 25 has 2 5s, 5 multiplied by 5, and power of 25 is 25. So that will be the power of 5 also. So we will have 125 out of the 25 to the power 25. Similarly, it will be same for 50 to the power 50. So we will have power of 5, that will be 50 in 50 raised to power 50. Similarly, it will be in 75, and also it will be in 100. Now we will find the sum of these numbers. 5 plus 10 plus 15 up to 100 is an AP, and sum of an AP is number of terms divided by 2, that is n by 2 multiplied by first term plus last term, and number of terms are 20. 5 plus 10 plus 15 up to 100 is number of terms are 20, so it will be 20 divided by 2 into first number is 5 and the last number is 100. So this is equal to 10 multiplied by 105. So this is equal to 1050. The sum of this 5 plus 10 plus 15 up to 100 is 1050. And 25 plus 50 is 75, plus 75 is 150, plus 100 is 250. So this will be 1050 plus 250 is equal to 1300. So the number of zeros at the end of given number is 1300, and from the given options our answer is option C, 1300. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find number of zeros at the end of the number 1 raised to power 1 factorial multiplied by 2 raised to power 2 factorial multiplied by 3 raised to power 3 factorial multiplied by, it goes up to, multiplied by 15 to the power 15 factorial. And the given options are option A, 5 factorial plus 10 factorial plus 15 factorial. Option B, 3 factorial plus 5 factorial plus 7 factorial. Option C, 8 factorial plus 10 factorial plus 12 factorial. Option D, 10 factorial plus 12 factorial plus 15 factorial. Before solving this question, I request you to please subscribe to this channel. In finding number of zeros at the end of any number is nothing else but it is power of 10 in the given number. But power of 10 comes from 2 multiplied by 5. So we will find the power of 5 in the given number, as power of 2 will be more than power of 5, as number of even numbers is more in 1 to the power 1 multiplied by 2 to the power 2 up to 15 to the power 15. So there will be more power of 2 than power of 5 in given number. So we will only find the power of 5 in the given number. So the power of 5 will be 5 to the power 5 factorial multiplied by 10 to the power 10 factorial multiplied by 15 to the power 15 factorial. So the sum of the power will be 5 factorial plus 10 factorial plus 15 factorial. And this will be nothing else but it will be the power of 10 in the given number. And this will also give the number of zeros at the end of given number. And from the given options, our answer is option A, 5 factorial plus 10 factorial plus 15 factorial. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find number of zeros at the end of the number 2 to the power 333 multiplied by 3 to the power 555 multiplied by 5 to the power 444 multiplied by 7 to the power 777. The given options are option A, 444, option B, 777, option C, 111, option D, 333. Before solving this question, I request you to please subscribe to this channel. Number of zeros at the end of any number is nothing else but it is power of 10 in that number, and 10 comes by multiplication of 2 and 5. So we have to find the number of 2's and number of 5's in the given number, and that will be 2 to the power 333 multiplied by 5 to the power 444, and this gives 10 to the power 333 multiplied by 5 to the power 111. So we have 10 to the power 333, and that will be the number of zeros at the end of given number. In given number, two more numbers are there, which are 3 to the power 555 and 7 to the power 777. But the multiplication of these numbers is not going to give us the number 10. So we have only taken two numbers, which is 2 to the power 333 and 5 to the power 444. And the multiplication of these two numbers give 10 to the power 333 multiplied by 5 to the power 111. But 5 to the power 111 is not going to give us any more zeros. Only we are going to get the zeros from 10 to the power 333. So number of zeros at the end of given number will be 333, which is the power of 10 in given number. And from the given options, our answer is option D, 333. I hope you have understood the method of solving such type of questions and the concept involved in this question. Here completes this video. Please like, share and subscribe to this channel, and don't forget to press the bell icon to get the latest notifications. Thanks for watching.